Let's try to build recursive intuition behind coming up with recurrence relationship for minimum coins to make change for target sum. So when we are thinking in terms of recursion, we'll keep two things in mind. We will stop as soon as target sum becomes zero. This will be our stopping case. And same way, we will stop as soon as we reach the last index. And here we know our last index is 2 in the example array that we are taking. Now, when you are at index 0, you have two choices. Either you can take index 0 element or you can leave that. And let me reveal the element and say this element is 4. So if we decide to take 4, you know that same coin can be taken again and again. So when we are at index 0 and if we take it, what happens is our target sum reduces to 8 and we are still at index 0 because we can pick the same coin once again. Now, from here, again, we have an option. Index 0 we will choose. If we choose and take it, we reduce it to 0, 4. Same way, if we again take it, we reduce it to 0. So you see, here we have hit a base case, which is target sum 0. Yeah, let me call it base 1. Whenever target sum reaches 0, we'll call it base 1. And when target index reaches 2, which is the last index, we will call it as base case 2. Okay, so we'll move back. Now, at index 0, you had a second choice that you can leave index 0 element. If we decide to leave, that means we are moving to index 1 and we are still looking for a sum of 4. Now, if we are at index 1, let me reveal the element there. Let's say the element there is 5. Now, think about you are looking for a sum of 4. The value present is 5. The value is way higher than our value. So we know there is no option here to take the value. So only option we are left with is to leave the value. So if we leave the value, that means we are moving to index 2 and we are still looking for target sum 4. And let me call it this is leave path. Now, if you notice, we have hit the base case 2. This is our base case 2 where we have reached the last index. Now go back up. 0, 4 is done with both the calls. Let's say 0, 8. Now 0, 8 would make a decision to leave index 0. If we leave index 0, that means from index 1 onwards, we are still looking for a sum of 8 because target sum doesn't change. Now at index 1, if we choose to take 5, that means we'll stay at index 1 and we are looking for target sum of 3 because 8 minus 5 will be 3. Now, when we are at index 1, you know the value is 5 and we are looking for target sum of 3. That means we do not have taking path, so we only have leaving path. And if we leave it, we land up to index 2 with a target sum of 3. Again, this also we are calling as this is our base case 2. So let's move back up. So now at 1, 8, and you took, that was the option. If you would have left it, then we would have been looking for target sum of 8 and we are at index 2. Now at index 2, let me reveal the value. Let's say the value is 6. Now again, we have hit a base case. We'll come and make some decision here. Again, we have hit a base case of 2. Okay, let's move back up. Now imagine at 0th index, if we would have decided to leave index 0, we would still be looking at sum of 12, but starting at index 1. Now at index 1, if we take 5, then we stay at 1 and 12 minus 5 is 7. At index 1, if we choose to take 5 again, we'll be having index 1 and 7 minus 5 is 2. Now at index 1, the value present is 4 and we are looking for a target sum of 2. So taking that is not an option. So only option we have here is leave it. And if we decide to leave, we reach index 2 with a target sum of 2. So this is again, we are hitting a base case 2. Coming back to 1, 7, if we would have decided to leave index 1, we would be going to index 2 and we would have been looking for sum 7. Okay, this is again our base case 2. Now going to 112, if we decide to leave index 1, we land up at index 2 and we are looking for a sum of 12. And this is again a base case 2. Now let's try to come up with the values, what we should return in base case 1, what we should return in base case 2. So coming to base case one, the moment target sum reduces to zero, we should be 100% clear that we have zero coins requirement to make the sum of zero. So this return value is evident. Now, coming to another base case two, if we are at index two, we are looking for a target sum of four. We know in any possible way, four cannot be made by using 6 rupee coins. So here we have to choose to return a value. Now, what value to return here is, keep in mind a simple funda. Whenever you are finding minimum coins, it's better to return infinite, maximum value here. So we will return infinite from this side. Coming back here, we are at index two. We are looking for three and value present is six. So it cannot be made. So let's choose to return infinite. Same way, come to base case two here. At index two, if we are making eight will be impossible to make. So we should return infinite here also. Now here again, we are at index 2. We are looking for 2. 2 cannot be made. Put it infinite. Here also make it infinite. But this is interesting case. When you land up at index 2, imagine if the sum desired was 6 or 12 or 18 or 24. If the desired sum is, if the target sum is multiple of the value present at last index, then you would definitely say, hey, there is a possibility. See, this can be 12 is a multiple of 6. 2 times 6 makes 12. Because it is a multiple, because 12 is divisible by 6, what we can return is target sum divided by 6. We can return an answer of 2 here. Hope this is making sense that when we are at last index, we have a definitive way of returning an answer. Let's utilize it further to build the overall answer. Now think about, we are at index 1 and we are looking for 4 and it made a call, it got infinite, so not possible. So here also we return infinite. Now coming to 0, 4, 0, 4 is getting 0 from left side. And keep in mind, when you went left, you chose this coin, and when you went right, you left this coin. So what this will do is, if we go with left, of course, we would have chosen one coin. So we have to choose kind of a minimum of 0 plus 1, left plus 1, comma, infinite. Out of these options, of course, left one is a better option. We get 1 as an answer. Okay, let's traverse other things. At index 1, you cannot make 3, so it is infinite. Now coming to 1, 8, if left also says we cannot make the change, right also says we cannot make the change, that means there is no possibility. So what we should ideally return is we should ideally return infinite only. Now coming here, left says 1, right says infinite. So we should be choosing minimum of 1 plus left answer or right answer. So out of these two, minimum would be 2. And this is the answer. To make 8, we need only 2 coins. Now coming back here, this is infinite, so this would also be infinite. For 1, 7, if left and right both are returning infinite, we should also say infinite. Now for 1, 2, left is returning infinite, right is returning 2. So what we should do is we should not consider left, we should consider only right. And right is by leaving this, so we should eventually have minimum of left answer and 2, which is 2. Okay, so this also moves back up here. Now, this also will move back up here. Now, 0, 12, if you take index 0 element, you're getting 2. If you don't take, again, you're getting 2. So taking is costlier path because now you will choose minimum of 1 plus left answer because left side you are taking and only right answer. 1 plus 2 or 2, the minimum is 2. So that gives us the final answer. Now, same thing we need to formulate as recurrence relationship. Let's write that recurrence relationship. So what we can do is we can say will be defined by multiple things. It would be infinite if both taking and leaving return infinite. Now, imagine if only left side returned a value, right side did not return a value, right side returned infinite, then we would say the answer would be 1 plus taking answer. This is second option. Third option would be if choosing a coin does not lead to a solution and leaving the coin leads to a solution. That was the case of 112. And the last one is, it would be, if both sides return some value, it would be minimum of 1 plus this. Let me call this as A, or let me call this as B. So it will be 1 plus A or B's minimum. Okay, so that becomes our recurrence relationship, well thought recurrence, where we have handled every case. Now, coming to base cases, we know that minimum coins of start 0 is going to be 0. If target sum is 0, the answer is 0. Next, if we say minimum coins, imagine if we have reached last index in denomination array, whatever the sum is, then there are two possibilities. If sum is divisible by d of n minus 1, then answer will be sum divided by d of n minus 1. Otherwise, if it is not divisible, the answer is infinite. That is what we saw earlier. So combining these two, of course, we got the answer. And now this needs to be translated into code.